Good day. I am Christian Jan Alado, ID 123, and today I'll be teaching FNDMATH LQ1, which includes equations and inequalities in one variable and partial fraction decomposition. For our next problem, we have another systems of linear equation problem in which now we're given four variables. So we have w plus x plus y plus 4z equals 1, 2w plus x plus y plus 2z equals 4, and w plus 3z equal 2, and 3x plus 2y plus z. So just to make our lives easier, let's assign each of these with a number, right? So for this would be our equation 1, this would be our equation 2, this would be our equation 3, and this would be our equation 4, right? So what do you want to do next? So basically, we want to once again manipulate the equations so that we can eliminate the variables and get the values of certain variables and then substitute it back. And yeah, we just have to repeat that procedure all over again or over and over again. So what can we do first here? So you can already see that we can already eliminate a lot, actually, a lot of variables in some of these, especially in uh, the first and the second equation, right? So in the first and second equation, we can see that x and y has the same coefficient. They have 1, right? So we can basically just subtract it to each other. And you might think na we can just multiply the second equation by 2 and then eliminate z, but that would mean that we can no longer eliminate x and y, and that would just give us with more or with larger values. So the best course of action here is to subtract them as is. So that would give us with w plus x plus y plus 4z equals 1, and 2w plus x plus y plus 2z equals 4, right? So now we subtract it to each other. That would give us with negative w, cancel, and uh, 2z plus 2z equals to negative 3, right? So this is 2z, right? Let me just 2z, right? So this we can assign as another equation, let's say equation 5, right? And now we can just proceed to the other, what do you call this? Uh, the other, um, the other equations first, right? So what we can do is use the third equation, since it only has two variables, we can use it to get the value of the other variable. So what do I mean by that? So what we can do is, since we have w plus 3z equal to, we can transfer, we can solve for z, right? So to do that, we'll have to transpose w to the other side and divide both sides by 3. So by that, we have 3z equals 2 minus w, then divide both sides by 3, and that would give us z equals 2 minus w over 3. Now, with this, we can then substitute z to the other equations. In this case, we want to substitute it to our fifth equation that we made earlier so that we can solve for w. Now, to do that, what we can do is we have negative w plus 2 multiplied by 2 minus w over 3 equal to negative 3, right? So what we'll have here would be negative w plus 4 minus 2w. This is all over 3 equal negative 3. So um, continuing solving this, we're basically will be left with We can multiply both sides by 3, so we can eliminate 3, right? Negative 3w plus 4 minus 2w equals negative 9. And combine like terms, we'll have negative 3w minus 2w. That would give us with negative 5w equals to negative 9 minus 3. Minus 4 rather, right? That would give us with negative 5w equals to negative 13. And we can eliminate this. We can get w by dividing both sides by negative 5. We cancel this, cancel the negative, we'll be left with w equals 13 over 5. Now we have our first value, which is w, and it's 13 over 5. Now what we can do is substitute this value of w to our equation of z so that we can solve for z, right? So we'll be having z equals 2 minus 13 over 5 over 3, right? So combine this, that we can multiply this by 5, right? That would give us 10 over 5 minus 13 over 5, which would give us with negative 3 over 5. So that would give us negative 3 over 5 over 3. And that would just give us with this cancels, right? So z would equal to negative 1/5. Now we can solve for the values of x and y. So as you can see, there is no equation in which x or y is alone with z or w, right? We always have x and y together in the equations. So what we can do is first we can use our first equation, right? Wait, let me just get more pages. Okay. Now, where was I? Equation 1. So let me just copy this. So we have our reference, right? So we want to once again use equation 1, and we can solve for either the value of x or the value of y, in which case I want to solve for the value of x, right? So let's have w plus x plus y plus 4z equal 1. So we want to solve for x. We just basically have to transfer everything else to the left side, to the right side rather, which would give us with x equals to 1 minus w minus y minus 4z. Now, we want, since we already had the value of w and z, we can basically substitute their values to w and z in this case. So that would give us with x equal 1 minus the value of our w is 13 over 5 minus y minus 4. And the value of our z is negative 1/5. Or, yeah, negative 1/5. So that would give us with, we can multiply everything by 5, but that would give us 5x. So we can just do, this would give us with negative 4/5, or sorry, 4/5, 4/5 minus y. And for this, we can use this as our sixth equation, right? So basically, we just combined all terms, and we were left with negative 4/5 minus y. And uh, basically, we have an equation for x, which we'll call as our sixth equation, which we will use to solve for y. And to do that, we can basically substitute this to the fourth equation. That would give us with 3 multiplied by negative 4/5 minus y plus 2y plus our value of z is once again negative 1/5 equal 6. We'll basically have to solve for y in this case, right? So to do that, we have here distribute 3 first, so that's negative 12 over 5 minus 3y plus 2y minus 1/5 equals 6. We can also, oh yeah, we can just transfer everything else, combine like terms, transfer everything else to the right side. That would give us with negative y equals to 6 plus 12/5 plus 1/5. You can multiply 6 by 5/5, so that would make our adding of fractions easier. So that's negative y equals 30/5 plus 12/5 plus 1/5. That would give us with 42/43/5. And we don't want a negative in our variable, so we multiply both sides by -1, which would give us with y equals 43/5. Now, we can basically substitute this value to the same equation, our fourth equation, so that we can get the value of x. So to do that, we basically have here 3x plus 2. Our value of y is once again 43, or rather negative, sorry. That's 2 times -43/5 minus 1/5 equals 6. And we just once again have to combine everything all together. So we get tx plus, that's negative 86, right? Or we can just transfer it to the right side immediately. That's negative, so that would give us plus 86/5 plus 1/5. Is that correct? Uh, yes, so that would give us 3x equals, that we can use again 30/5 here. So that would give us with 30 plus 1 plus 86, that's 116, and 117/5. We divide both sides by 3, and x would be 39/5. There. So now we basically have our complete values. I'll just copy and paste them. So we have for W, copy it here, paste, W, X, then Y, then Z. There. So basically that sums up our values for W, X, Y, and Z. Here we go. Just box this. There. And yeah. Thank you so much for watching. You may also avail syntax tutorials by scanning the QR code flashed on your screens. And once again, this is CJ from Syntax, paving your way to excellence.